Good evening and thank you all for joining us today. My name is Rashmita and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He's passionate about technology and works on Azure, GCP, machine learning, and blockchain. He's also Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you, Rashmita. I will quickly share my screen. Okay, so just give me a minute. Okay, so I have the chat window open in the secondary screen. And whenever you guys have any question, please put the questions in the chat window. I will take the questions on the way, and during the end of the session also we'll have the Q&A. So let me just quickly open the agenda for the day. And if you are joining us, you must have realized by now that we are doing a series of advanced AI solutions on Microsoft Azure using their machine learning services. And today we are going to talk about the uh, NLP with Azure machine learning service. So in case you have not joined us for the previous sessions, you can find those sessions on Microsoft Reactor on YouTube, and you can uh, definitely go and have a look at that. Okay, so today we are going to cover things from over here. And the very first thing which I want to do is I just want to share the learn module link in the chat window. So the so after the session, this if we go to this particular module link over there, it opens on Microsoft Learn, and whatever we will discuss, all those things will be on those pages, and it will be way more structured, and you can spend more time going through the entire all the topics and all the hands-on, all the labs in a very structured manner. So, okay, so if I just walk you through that, now we have both the variations of that, PyTorch variation and the TensorFlow variation for NLP, right? You can go through both of them. Now, basically, they both will be having a few units over here. You can click on these units and you can uh, have a look at that. They're like exactly matching apart from the different framework over there. Now, if I click on any one of them and I just want to show it to you. So if I click on the, let's say, introduction, we have different units on the top, right? So whatever we will discuss today is on that page. And this is one of the link which you can follow or which you can go to after the session to do the hands-on tutorial or whatever I will show you. Everything will be there. You can also do it. You don't even need Azure subscription. You just have to log in with your email ID over there. And once you do it, you will be able to see something like a sandbox there, which should load somewhere on the top of the page here. Like this, you can activate the sandbox and you can do all the tutorials over there. So sandbox is like it's like an Azure account, which is given by Microsoft for you to do self-learning. Okay, so this is what we can do after the session. Let's see what we are going to cover today. If I just walk you through the various things which we have over there. So we will be understanding a different type of task which we can do with NLP over there. Text classification, intent classification, sentiment analysis. We'll see how much can we cover in 60 minutes, but just to walk you through this, sentiment analysis, entity recognition, extraction of the keyword summarization, and Q&A. Now, if I just go to the next module over there, we have this module where the as you already must be aware of that, it's not possible to work with strings as it is, right? We have to represent them in some numeric format, which the algorithms can use to do something with that. So that's what we are thinking of here. That can we represent the text as tensors? Then we think that can we do something which is having less dimensions and maybe it's better. So can we do some embeddings over there? And then how do we work with RNN? What's the meaning of RNN and LSTM, and how will they start remembering these states and then generate some text with RNN over here? So you can do this particular module where at the end of it you will be seeing that you have generated the text as such. Your model will generate text now, and then the ending happens with transformers and attention models over there. So it will take you a lot of time to understand the attention mechanism and so on and so forth. So I'll do my best to summarize it, and then you can spend your time into going into more depth over there. Okay, so this is what we can do after the session, and the link is there on the meetup page. It's also in the chat window. Please bookmark it, and we can go through that. Okay, so now where is the Azure machine learning part over here? Now today's session is for somebody who you will be able to, so we are starting from scratch only, but we will be working with Apache Spark as part of Azure Synapse along with Azure machine learning. So what we are thinking of is how can we leverage the distributed computing which clouds can provide, and one of those, the framework is Spark. Can we have the Spark framework in serverless manner? And can we submit the machine learning jobs on Spark? And those machine learning jobs can be a NLP job. And how can we have some pipeline created around that? So we will understand all those things as well. So and just FYI, so all of whatever we are discussing today is about the Azure Synapse Spark is mostly in preview. So we are going to discuss the concepts which are as cutting edge as possible. And maybe if somebody is watching this video in future, then they will be at the time, maybe all the services are in GA. The Spark part of it, right over here, this one. Azure Machine Learning Service is there since many, many years. I used to use the old version of this in 2013, the studio, and this is the new supercharged version of it. So Azure Machine Learning Service is pretty mature, but the connectivity and the Synapse Spark pool is something very, very new. Okay, so a little bit of setup. Let me walk you through all of this. Now we may have covered all of these in more depth in previous sessions. So if you find that the machine learning service is you need more time to go through it, then you please find the previous sessions on YouTube. It's part of the Reactor channel there. Okay, I'll just open my Azure portal. I'll show you the one setup which I have done. It took me a few hours to do the setup, so I have the setup ready with me, and I'll walk you through this. I'll show you. I'll walk you through the entire setup, all the line of codes, everything, everything, all the concepts, and so on and so forth. So check this out. So this is my Azure portal. I have one resource group over there, Azure Machine Learning resource group. So what I have done, I went to my VS Code and I just created one workspace. I'll zoom in for you. So check this out. So this is my VS Code, and what I have done, I have just logged into Azure. That's one of my dummy subscriptions for the demo purpose. So I'm selecting that subscription. Created one resource group over there in EastUS, which is called as Azure Machine AML RG. Had to install some of the command line tools for the CLI, and then created one workspace, machine learning workspace. So this workspace is there inside my resource group over here, one of them, that one. So we'll go inside that, we'll have a look at it. And that's the one which I have in the diagram on the left-hand side, this one over there. So apart from this, I have just executed few more lines. I have listed whether it got created or not. Couple of things to do this setup. Couple of extra services needs to be registered. So I have registered those extra services. Synapse is there. Uh, Microsoft SQL by default in new subscriptions is not registered. So you have to register all of this. Now, please do mute yourself, right? You can hear the background. Okay, so right now, if you have questions, just put them in the chat window, right? We'll have the Q&A in the end of the session. Okay, now, so have registered couple of more, have registered couple of more things over here. So these are resource providers. If you're aware of it, these are the service at the backend which do some particular type of job for you. Created one ADLS Gen 2, which is data lake, right? HDFS replacement data lake in Azure. So this is that. Inside that ADLS Gen 2, I have created one file system. File system is basically one container there, which is equivalent to HDFS share. So that's the this is the name which I have given of that. So this I'll show you this in the portal as well. So I just executed these few commands here, then created one Synapse workspace also, which is called as Shivam Synapse workspace, and it is connected with that ADLS Gen 2, which I have created over there, and some firewall connectivities. Now I whitelisted everything, so I don't have to worry about the network over there, but you can whitelist your own IP addresses. So because generally when we are working from home, the IP addresses are given from the internet service provider, and uh, I don't want any complicated script to break somewhere in the live demo because of the switching of the IP address from the ISP. So whitelist everything. Now, secondly, the created one Spark pool. This thing is this thing over here. You see the right side. So we have this Azure Synapse over there. I'll walk you through that. Just wanted to show you the setup in the CLI which I have done over there. Now, so and you see this these executors which we have. That's the Spark pool. So that Spark pool is coming up in this line, and we have named it as Spark pool 01. And we'll see what it does, what's the meaning of it, and we have listed everybody out. I'm using Python 3.8.12, and I have this environment created in Anaconda. And apart from that, so all of these instructions will be there in the learn module as well. But just to show it to you, these are the exact libraries and the versions which we are using. And if you recommend for the demo which I'm showing, if you reproduce it later on, just keep it like that only. Otherwise, you may have to struggle with some few things as such. Okay, now, so okay, let me zoom out. It's too zoomed in. Even I cannot see what is going on there. Okay, so I was using, as usual, if you have joined me for the previous sessions, I was using my laptop to do all the deep learning setup, but my laptop after a few hours of setup just got stuck. So what I did which everybody I should have done in the starting, go to the cloud. So now this is my Azure machine learning workspace, and sorry, that's the resource group. This is my workspace over here. So this thing which you see is what we have on the left hand side over there, and the Synapse workspace is over here. So if I just walk you through that, this thing which you see is what we have over there on the right hand side. So let's go and understand the concept first, and then we'll come back and read the various steps over there. So now I'll just show a couple of things over in Synapse first. So just FYI, Azure Synapse Analytics is it's a suite of products. It's basically having multiple things inside that. You can create four main things over there. One of that is called as Spark pool over here, this one. So which is a Apache Spark cluster where you can do machine learning, data engineering, and you can run any Spark job over there in this one over here. Now, apart from that, it can do many more things. We'll discuss it in some other session, but that's our warehouse, and it can also do some ETL, ELT as well. So now what we have done We went to Synapse, and in Synapse, we have created the Spark pool. If I just show it to you, I have just done this with the from the command line, but this is what it has done with the default setup. So if you have a look at this, some name, isolated compute means at the backend, do you have dedicated machines or not? We don't have dedicated machines right now. What type of family? I have in my existing Spark pool, I have around 300 GB of RAM, more than 300 GB. We'll see it. Around 48 cores are there. You can do auto scaling. You can specify number of nodes. You can specify that executors will get created dynamically or not. Then you can also specify which Spark version. So I'm going for the 3.1 only, and it will terminate automatically after 15 minutes. And rest of the Python 3.8 and so on and so forth is supported in the Synapse Spark. Okay, so we have done this, and if I just cancel this and show what we already have, this is the existing one, and uh, so we actually have all together. Let's see, not here. Okay, let's see over here if it shows the entire configuration. Okay, so we have 48 cores and around 384 GB RAM, which we can work with over there. And it's already like how much is allocated, how much is not allocated. Okay, that's all. So this is so we have just created one Spark uh, pool in Synapse. So what it does is, if I take you back, so one of the problem with deep learning will be it takes time, right? So if you can distribute it, that will be great. And Apache Spark is one of the is a very good solution, as you may have already realized by the previous sessions which we have done. We can run the deep learning jobs on Kubernetes based Spark as well, which we have discussed earlier. This is like yarn based Spark, the normal one. So right, uh, yarn based Spark. So what happens? We have created the Spark pool. Now, when you create the Spark pool, it only creates one configuration. Nothing comes up. Like what I created over there, that didn't create any cluster. There is nothing which is running. It's not costing me right now. It's just one configuration, which we are calling as Spark pool 001. And it is having some X number of cores and GB of RAM over there, which we would like to use later on. So it's totally empty. There is nothing there apart from some configuration. So now generally what happens is the data scientists or data engineers, they open let's say if they open the Synapse workspace which we were looking at directly and they start working with it, it's pretty good. But the problem will be that it is not having the advanced functionalities required for the pipelining as such. Like when you work with machine learning, you would like to uh, let's say you are making few chatbots. So I think I have it somewhere here. Let's say there is a chatbot which we have deployed somewhere. So this model needs to be registered somewhere, right? Like it should be saved somewhere. Like you have GitHub for code, your model should also be having a registry where or model management is important. So Synapse is actually the main machine learning service in Azure is Azure Machine Learning Service. That's the name of it. This is the Azure Synapse is a suite of product, and it is having multiple more things. And the best thing is Spark over there. So if I use this directly, I will you can say will face issues during my model management, during containerization. If I that particular support or that particular product which is having all the capabilities for machine learning is not exactly Synapse. So what we don't use it directly. We do the way it is done. We use the machine learning service of Azure, and whenever we require the power of Spark to distribute or to run our machine learning jobs parallelly, we attach it. So you see this attached compute. Now, if I take you to my machine learning service there, check this out over here. So this is the portal where all the custom machine learning is done. This is where everything is, you can say, this is the one which is as standard as possible or is having all the functionalities in the world and so on and so forth, whatever, right? So now here we have notebooks, AutoML can be done. We have designers. Designer is something which is eye-catching, so I will just show it to you. So if I click on it, you see this over here. Uh, it will It's pretty self-explanatory, but you see this drag and drop functionality. This is designer. So now we have data sets over here, experiments, pipelines, model management. This is the model registry, which we will love to have when we are doing uh, in your, let's say when you will operationalize the model one day in production, then you will be needing that. Even if you don't operationalize it, you still will be needing some location to version your models, the previous trained models. Now, this is that. Endpoints are our endpoints, the API endpoints. We will be thinking about retraining uh, once the models are deployed. Okay, compute is where we will click first. We have compute instance, cluster, inference, attached compute. The middle two we will skip for today. You can go to the previous sessions to have a look at that, right? So today, what we have is we have the attached compute, which is Synapse. So what we have done, we click on the attached compute, and this is where we click on new and this one, and then we fill up this give a name, connect to Synapse workspace, done. Then go to Synapse and click on management, access control. Here, if you are aware of managed identities, we have discussed in few sessions before, MSIs as such. So every resource in Azure, to talk to any resource in Azure, needs to have some authentication and authorization. So there are mechanisms by which we can do that. Service principal, user assigned MSI, system assigned MSI. So the one which comes up by default is system assigned MSI. So this yellow dot is the identity which got created in Azure machine learning service, and I want to give it rights on Synapse. So later on, I can do my Spark summit of the NLP jobs over there. Now, to do that, I went back to Synapse and just basically click on add and gave the rights to the MSI from here. These are a few of the rights which you can give in at the Synapse level. So the one which is required for this setup to work is this one, Apache Spark Administrator. So machine learning service can submit the Spark job and can get the status from there and do the overall management of it. So it's a resource to resource level authentication and authorization, which we are trying to achieve over there. So we have done it. And now if I go back to my studio, this comes over here. Everything is successful. Now compute instance. So this is, I was using my laptop earlier. That's me over here and my laptop, and it didn't work out. So I couldn't use it. So what I did, I went to the cloud. I created one little more powerful machine. This is called as compute instance. So compute instance is the development environment which you can use in the cloud in case and inside this environment, inside this machine, all the standard things will be there. Jupyter Notebook and Jupyter Lab and all those things will be there anyways inside it. Now so that's where we are right now in compute instance and like this. So what is this? Development environment. Okay, in the cloud, and you can specify how much RAM you want, can be CPU, GPU based development environment. So better than our hardware. Now, so this is where I am right now, and this is how it looks like. So if I just zoom out first, it's too zoomed in for me. And if I click on the left-hand side from here in the notebooks, so this is where my notebooks are there, from where I'm working right now. I have few of the folders, like how can I train my jobs in Spark. So train in Spark, some more jobs over here to deploy the model in Spark for some. So Spark is pretty fast, right? Because of many features. You can go back and check out the distributed Spark session which we did few weeks back. So now, so we can also deploy the model in Spark. So it can do some real-time inferencing if required. This is that, but that's not what we are going to talk about today. Today we will be talking about this one over here, and this one over here. I think so. That's the one which I created. Submit as a job. Let me just read the other one. Yeah. So interactive. Okay, so you see this interactive session. For example, if you, so what we are going to cover is like is a job-based submit. Like you make your train.py and you submit it. For example, if I go back to the diagram, you see this train.py, data prep.py. You make these different files, you make the job and you submit it, and that's all. You just go grab your coffee, right? And the other way around can be that you don't do that and you interactively work with Spark. Interactively will be like in one-to-one manner, command based. You run one command, wait for the output, and so on and so forth. So not job based, where you cannot go and get a coffee. So we are doing the one where we can do it in a better manner. So I will just take you back and we'll zoom out and we'll see the important part. So this is the Azure ML part. Now here, only one change will happen where you see this train.py file, the over here, you see this data prep.py, train.py. These are the NLP jobs over there. So once we see the overall structure, we'll just go and we'll go and get see the NLP job over there. So in future, whatever we are doing right now will remain same. You just have to swap your jobs over there. Rest of the things can remain same with no change. So just change these files over here. Now, for example, if you go for TensorFlow versus, if you go for TensorFlow versus PyTorch, then some more changes will be there. But if you stay in one of the frameworks, then things will remain more or less same. So, okay, a couple of basics over here. We have to connect both of them. So what we want to do is from Azure Machine Learning Service, we want to use the Spark functionalities of Synapse. So we have to connect to that. So we are importing few of the packages over there, which are useful. And few of the main differentiating packages from any other normal Azure machine learning configuration will be these. So you see this HDFS output data config. So basically, the Spark requires HDFS location, or it requires either real HDFS Hadoop distributed file system to read from, or something which is having a Hadoop driver over there, like data lakes can have Hadoop drivers, ABFS drivers. So, or even blob storages work, like the Spark clusters, they can read from blob storages as well. So we have to specify all those things. So this is where the changes are there. And one more Synapse compute is there. Apart from that, rest of the things are more or less same. We are working with this linked services. The rest thing is different. Okay. And apart from maybe this one more thing. Now, then we connect to so this is where we are just authenticating my browser, or you see whatever you see in the screen is it authenticated with Azure Machine Learning Service or not? That's what will happen in this line. And then, okay, so this is where I have hard-coded things right now. These are my dummy accounts, so it really doesn't matter, but all these values will be in your key vault. Or you have to manage it with some environment variables, which you can put in key vaults. Now, so we need the subscription ID, resource group, name of the Synapse, and the Spark pool name, and then we do the connectivity to that. And the connection is already done. We are just using the same names over there. So it says that, yeah, experimental class will change in future and so on and so forth. So it is pretty new today. Everything is in preview, but right. So then this is what I was telling you some time back, that you have to go and give the rights to the identity to this over there. So I have already done that part before. So we can simply proceed with this. And okay, now this is where we do the attachment of both the solutions, where we are attaching the AML service with Synapse. So how do we do that? We need the name of the Spark pool, which right now is existing. That's the name of my linked service which I have created. Sorry, this is the name of the attached compute which I have created over here in the previous page. So over here, this name, that one is that one, and that's the name of the Spark pool really inside the Synapse over there. Then things are pretty straightforward from there. We do the attached configuration, and we use this as the attached compute. Now, one thing which we will appreciate about this what we are doing right now is, from the data scientist's point of view, he or she will be able to submit the job which are distributed in the Spark cluster, and he or she may not have to deal with all the complexity of doing that. It will be if they already know, if they already work with Azure Machine Learning Service, then this is very similar to what we normally also do. Like we create some attached computes or normal compute targets as such. So it will become very straightforward for data scientists or maybe AI engineers or machine learning engineers to work with Spark. The learning curve will be less, or and they can be more productive. They can focus on their code, and once if we set up the pipeline properly, then it's very modular. We can swap components later on as per need with very less changes over there. Now, okay, so now we are doing some data preparation, and then if we just check this out, so we have two type of data sets in machine learning service: tabular and file data set. So when we are going to submit the NLP job, the data, that big amount of chat data, will be somewhere in the world, right? So the metadata, so data sets are basically metadata. So these are pointing to the location where the massive amount of data is kept. That massive amount of data can be kept in data lakes, which don't have any limit. So they can be in Azure storage account, which are having 500 terabytes of upper limit over there. So now, so we have to specify those file path. So that's what we are doing. And then we are passing this particular data path to the Spark cluster in the HDFS output data config. And then the Spark cluster will be able to get the data from there. And any intermediate step which needs to be done will be also can be written in these type of locations. Now, if you are aware of natural language processing, which we are just going to jump into now, you will be aware of that a lot of data pre-processing happens over there. Uh, and once you have done it, it's pretty simpler after that. So a lot of time will go in the processing of the data. So what we are doing is we can create different pipelines as such. So from pipeline, I mean really this. I can show this to you first. So if you can see this over here, we can create pipelines like this. Like we can have different data sets coming from different location, like step 1, step 2, like that. So pre-process the data, do some other transformations, and then train, and then after that more steps over there in the flow. Now, so for that we modularly define the jobs. So we are defining two jobs right now. We have the data the preparation job, and the training will also be there. Now, apart from this, some normal arguments are passing. These arguments are like runtime arguments, which will parameterize your code, and you can simply swap one data set and different, you can say, uh, train.py files using the arguments over there. Okay, so now, okay, so this is where we are using the script run config, which is the normal way in which we work with AML. But right now, we are submitting the job in the Spark cluster. Now, if you're aware of the Apache Spark, we have executors there. Like in Apache Spark is having a cluster manager called as Yarn, yet another resource negotiator. And that resource negotiator is having two components: the resource manager and the node managers as such. So those things are there in the Spark cluster over there. Now, what are they managing? They are managing the executors and the drivers. So what is this driver? What is the executor? This is where your job will be actually running inside the Spark cluster. So you see these the yellow boxes which I have. These are being managed by the cluster manager inside Spark, which is not in the diagram right now, called as Yarn. And whenever I submit something, I can do many things. We can have dynamic executor allocation as well. We can statically also do it, which we are doing right now. Sometimes what happens, dynamic execution may work out or may not work out. It may you may have, see, things are very practical. Big amount of data, deep learning needs big amount of data, and when you have big amount of data, if you are doing distributed computing, data will move around. So sometimes the shuffle job which is there, which means like data is moving around from some stage to another stage, that can slow down your overall training. So at times the dynamic executors may not help you out. You should be able to calculate it yourself, like what you are doing, you should be aware of it. So we have both the options. So we can do something like this. We are saying that, okay, give us one driver, sign up Spark, give us one driver, 1 GB, 2 core, give us executors over there, 1 GB, 1 executor, 2 executor. You can specify things here. And then we create the script run config and we do a simple submit. We just specify the config. So we create one folder called as code folder, which can be having any other name, but basically it is the one which will be submitted to the cluster. So this is going to be uploaded. So don't keep anything very heavy over there. Like don't put your data there. The data should be somewhere, practically data should be somewhere in these data stores like SQL data lake, and then the reference of that should be passed to your cluster. So that data store can be mounted to the cluster and then it can execute over. Now, and if you keep it here, it's literally going to be uploaded. So if I keep something very big in this location, uh, that may not work out, right? So okay. Now, if I just go back, the okay, so we basically do the spark.submit, and this is where the job starts running. And if we go back to the monitoring section in Spark, apart from so if we have to go to the Spark application and it will be visible here, you can go and maybe click on few of them to see what has happened. Now the UI, if you already know Apache Spark, I'll just show you one UI and then you can later on relate with it. So I have that page open with me because it took a few minutes to open. So this is that same job. I just kept it open. So this is like this is the normal Apache Spark dashboards where we have with the DAG visualizer and all the different things are there. How many jobs are there? So you can find how the executor was properly used, not properly used, and all those things can be understood from there. So to do this, you just have to click on this option. It takes few minutes to open, so I kept it open for you. And this is where my job has executed over there. And it says that the executor is not utilized fully. I gave more, I allocated more resources and my data set was not that big. So I have to do better calculations. So this is where maybe that dynamic executor would have work better. So this is somewhere, but we get the full report. We are able to, we'll further go and modify that. Okay, so this, if I take you back and let's go inside the NLP part now. So the data preparation is done. And I think it scrolled up. Maybe I opened another tab. So yeah, okay. So okay, so I'll come to this part in few minutes where we are working with the pipeline over here. So AML pipeline, I'll make you understand how this pipeline makes a lot of sense in all the ML jobs. Just give me a second. Okay, so if I take you to the, okay, let's go to the, let's jump into the in the NLP job now. So the very first thing is we have to do a lot of pre-processing of data. So when we submit your, so when you want to work with any text data, you have to represent, you have to represent that in some numeric representation. So I have opened the page which is there in the chat window, and it's also this a learn module which I was showing you earlier. So okay, so just like your laptops also, whenever they display anything, they use some sort of encoding. You may have a UTF-8 encoding or any other encoding as such to represent the characters. Similarly, when we work with the text data, we also have to represent the data in some numerical format. So we can do character level representations and word level representations as such. Now, the example which we have over here is basically a data set which is called as AG news data set. And there are 4 categories where the classification needs to happen: world, sports, business, science, and tech over there. So the text needs to be classified in this category. So we are using the torch text and torch, which is PyTorch over here. And so this is one of the data set which is available inside the torch text. So you can simply get it from there. Otherwise, this is where we can also, where we have earlier passed the reference. So this is like the standard alone code, but when we merge this with AML over there, what I was showing you earlier, that is how we will do it. Like we'll upload the data in some, it is a toy data set, but when you'll have practical data set, you'll upload it in some location, and then you will pass the reference of that location during using the data sets. Now these are iterators. You can iterate over there. If you say something like next, it will show you the next value. You can loop and print out the values as well. So you can see the labels are here, and this is where the headlines of that news of that particular news article is there. So this is we have labels over there. Now, uh, okay, so okay, now okay, check this out. So for example, if I give you any piece of text, one of the steps which we need to do is tokenization. What tokenization does is what you see over here. If the input sequence is he said hello, then the tokens are he said and hello. 3 tokens are there. We can have single unit unigrams as well. We can also have something like where this is happening. So where, if you can see that here we have tokens which are combinations of two uh, two words over there. Like single words will be like hot dog, and the bigram combinations will be like hot outside and it's hot and so on and so forth. So those type of things we can do with during the tokenization process. We can specify that it will preserve some context. Now, okay, so a couple of interesting things over here. This is the collection.counter. That's basically the one of the main things. That's the dictionary where the keys will be the elements, and the count of the elements will be the value of the key over here. And then this is where what is we are updating using the tokenizer, which we have used, which is available in Torch text. You can use something else also, the basic English uh, tokenizer of that. And then we are creating one vocabulary with that, and we are saying that if the count is let's say if I use this example, he said hello. So he is having one count right now. So then that is okay. It can be part of the vocabulary. That's what that minimum frequency one means. Now we okay, this is where we are getting the indexes of that vocabulary value. And one of the representation which we do, it will take you time to go through all of this which I'm covering over here. So that's why the learned modules are given. But the one of the so there is a thing called as a bag of words. Now in bag of word, what happens? For example, if uh, you can say if you are representing a text, so and if the order of that particular sequence doesn't matter as such, uh, then in those scenarios, bag of words will make sense. So these are the vector representations, which are the old representations, or they can still be used. So traditional vector representations, each word is linked to a vector index, and then the occurrence is basically over there taken care by them. So after this, so this is in the first module, we do all of this. We can also do the tokenization with the help of the bigrams and the in the trigrams as such. And then once we have done that, we go to the advanced versus the previous one, advanced embedding techniques. Now, what was happening in the previous example? The output vectors which were there were very sparse. They were very big, having a lot of zeros and very less ones over there, or data was less and more. The representation was through a sparse matrix. Like sparse bin matrix is a type of metric which is having more zeros. So now if we do embeddings over there, then we will be able to use the low dimensionality and the dense the representation of that. So this is very interesting, and you may already be aware of it. You may have seen this somewhere. So if I show you the example, which is the most common example, uh, and I'm pretty sure you all already must be thinking of that. I'm going to show you that king minus man one. So which is there in our lab, and if you see what we do over here, or just give me a second. Yeah, okay, this is what I wanted to show. So uh, like in English, I can say that king minus man plus woman is what, right? So if you really think it through, if you take it as a puzzle, you may say that, okay, king minus men plus woman must be queen over there. So this is what we are doing. We are saying that, okay, what is near to king and woman, but should be as far away from the men word as such. So now what we have done is we are able to now you are able to do mathematical operations on the words, because they are now represented in these embedding, and they are maintaining their you can say semantic relationships. So you can say things which are having similar meanings are in one near or smaller vector space as such. So all the mathematical operations can be done on top of it. So this is something which you would like to go and do it. It will be pretty interesting to find other relationships over there. Okay, now once we do this, all of that, the next interesting part which we have is the recurrent neural networks, and these are the ones which are able to. One of the problem which we face in NLP is that if you the sentence is having context, like whatever you speak depends on the whatever you have spoken before, or everything is depending on each other as such. So how do you basically uh, preserve that, or how do you basically use that? So this is where the sequencing comes, and we have the de facto RNNs, which are now not very popular because transformers are already there. But they were a few years back, they were the things to go for. Okay, now so one of the problem with normal recurrent neural networks were that they were not very good with long sequences. So if you speak in very long words, sorry, long sentences as such, and the starting of the sequences is related to the end of it. Maybe you have very pretty nice vocabulary and way of speaking, right? Then RNN will not be able to help you over there because they will not be able to maintain those long sequences or the context in the long sequence. So we have LSTM over there. Now LSTM is very intuitive. It's very similar to how we also work. Like it has a concept called as forget gate. Uh, Mathematically, in input gate output gate. So for example, let's say if you have I'll just give an analogy and will relate with it. Now if you learn something, let's say you have learned Azure or maybe any other cloud as well, and when you started doing your experimentation, you understood it wrong, or maybe you maybe got it wrong, or you had a wrong understanding of it, and then later on you want to forget that old information and maybe want to put something which is more relevant in that point in time. So that is the concept behind the forget gates. Now, similarly, we have input gates and output gates. So you can add more information in your hidden state and in the memory as such, and you can use it. Now, so this is where LSTMs were very well. They were working good. LSTM, RNN were ruling the world. Then what happens? Transformers came out, and then transformers are these very complicated. You can say are having a pretty complicated RNN architecture where which I will use my own diagram to explain further. So I did one session few months back for somebody. This link is of that diagram which I'm using. So it's in the chat window. But if I just click on the architecture, this is how this is the non-expanded version of it. So that's a very simple transformer. It came out in the original paper, which is called as attention is all you need. So we have the encoder and the decoder, two blocks are there. And this is, and that when expanded looks something like this. So I'll give you a 2 minutes overview of this, and you really have to spend more time into going through the document. But what it does is very interesting. So imagine you are sitting over here. You are right now here where I'm moving my cursor, and that vehicle is coming towards you. So where is your attention in that point in time? You will not be focusing on the background as such. You will be focusing on some particular part of the text, or some particular part of the input image also. So the attention will be on this part versus the background part, and less attention will be on the other vehicle, because if you escape from this one, you may have you may be maybe you may have to avoid, you should avoid that also, right? So how do we do that mathematically? So the next thing which we look will be very big, but I'll show the interesting part. So what we do is Uh, okay, so what we do is, let's say we have the input data, we made the vocabulary, we have the indexes created. This is the embedding layer which we were thinking of few minutes back, and this is so the example is here is an example. You see this here, here is represented by this vector over here, which is having some representation of that. Now now what happens is this is not sufficient because position matters. For example, if I show you this statement somewhere, which I should have written here, right? So let's read these two statements. And these are, I think I got them from the white paper only. So these, it's not my creation. Uh, Even though she did not win the award, she was satisfied. The second is, even though she did win the award, she was not satisfied. So that position of not is very important. It changes the full context over there, right? So how are you going to put that? So we have one additional thing called as positional embedding. So what these positional embeddings, you see this P0, P1, P2, P2, and these were the embeddings, the word embeddings over there. Now what we do, what these positional embeddings will do, they will give the context based on the position of the word in the sentence, which exactly means what you can understand from these two sentences over there, like the position matters a lot. So the before the things go inside the transformer, we will add both of that, the positional embeddings, and we will create the embeddings with context. So these new embeddings which we have, EP0 and EP1 and so on and so forth, this is the order aware embeddings, the sequence matters over there. Now, okay, so what is happening in this block is what we just discussed there. That, see, it's very important. Humanly, you can do that. You can literally subtract. I'll use the easier words. So you can remove the background. You can lay more attention into on the main part of the input sequence or the text or the just FYI, transformers also work for images, right? So this example totally fits over there, easy to explain. So you will be focusing on this part more versus the background as such. But how will you mathematically do it? So for mathematically doing it, we have to do a lot of things over here. Different type of matrices are created, Q, K, V. Now, finally, what happens is the main thing which happens is the attention mechanism is that the output which will come out of that the output metric which will be there will be having the filtered value. This is the one where more attention or focus will be there on the main part of the context or of the image, which in very simply you can understand is right now that where you are staring death in face over there, or death is face staring you in face as such, and that's where your attention should be to avoid that, right? So this is what happens in this block over here mathematically, and then we get the high focus input outputs over there. But as you know, in machine learning, nothing is done once. So in the original paper, actually eight heads were there, eight times it was used. So we got eight output: Z1, Z2, Z3, Z4, Z5, Z6, and you can play with this. You can make it more and less. And then we merge it out, shrink it, and then we do some normalization on top of it. Then some output comes, some residual, some more things over on top of it. And then finally the input is sent to the decoder over there. And then finally in the end of it, you will get the output. So now what are we able to do with this transformer is we are able to uh, first of all train the models very fast. We are able to load data parallelly. This is you can say transformer will be used or all the good things which you have seen as such maybe today, they are results of transformers. And now they are way evolved. The one which we have seen was the original white paper. And the you can say we have Bert as well. So Bert is one of the transformer multi-layer transformer architecture which is trained on Wikipedia data, and it is having millions of parameters, and I will just billions of parameters as such will be written somewhere. So we use these type of pre-trained model because generally you or me may not be having the resources to train uh, extremely big deep learning models, because it takes a lot of CPU, GPU, GPU and TPU as such, tensor processing unit. So it becomes very expensive for individuals or for smaller companies or mid-sized companies or for big companies also to train these. So what they do, they use the pre-trained one from other companies like from Microsoft or from Google or from Uber or from Facebook. And if they train something, then we use them, these pre-trained ones for our NLP jobs as such. So this is what we have over here, where we are using the pre-trained one for text classification called as Bert, and then we are able to use it by the end of the session over there of this demo over there. Now, so this is what we had planned for you in today's session. So if I just walk you through the next step which you have to perform, you can literally go to the to this meetup page, and that's your learn module. I will give that in the chat window. Keep it with you. You don't even need Azure subscription to work with it. Everything is available in Sandbox. And uh, over there, and you can try out the TensorFlow version. You can also try the equivalent PyTorch version for that. Okay, so I'll just go through your questions which are there in the chat window, and you can also ask your questions if the mics are unmuted. So I'll read a few of the questions which are in the chat first. I usually run CLI from command prompt. Yeah. In VS Code, if you want to run that .az CLI, basically an extension is available. So in VS Code, click on extension and search for Azure CLI extension, and that extension is pretty interesting. That's how you saw that. We don't need it's so editor was missing in normal CLI, so this is having editor. Okay, what's the difference between Synapse Spark and Databricks Spark? Okay, now, okay, so the backbone is the Spark only, but the Databricks is a separate company. Databricks is the company who the creator or the founders of the Databricks are also the people who did the most contribution in the open source Spark also. So they started their own company called as Databricks. That on Azure is Azure Databricks, which is uh, which is proprietary Databricks as such. So uh, it's a different flavor of Spark. It has its own pros and cons. Uh, and the Spark which we have inside Synapse is also called a serverless Spark pool because it's a job-based thing. When you submit something, then the cluster comes up. Otherwise, the cluster is not there. Only the configuration is there. Now, this is based on the open source Apache Spark, but not really. They have done a lot of uh, uh, edit, or you can say they have Azure has made its in its own flavor. So one thing which is there is we have hyper space is one of the indexing mechanism which is pretty interesting, which first came in Spark, then they open sourced it in Synapse, then Microsoft open sourced it. So all of those type of things are there, which are there. So generally, if the customer is looking for only Spark functionalities, we go for Databricks. If they're looking for the suite of product for analytics, having warehouse, ETL, ELT, Spark, we go for Synapse. That's the answer for that. Stop word removal definitely needs to be done as well in the pre-processing steps. What all languages are supported in tokenization? It will be a very big list. Nearly everything is supported. You will find all the native languages of different countries and so on and so forth. So just give one Google search on it, and you will find huge list. I'll also share if I find something in my secondary screen. Uh, One hand is raised. Yeah, please go ahead.
Yeah. Hello, am I audible?
Yeah.
Yeah. So my question is, like Bert, we cannot train from the scratch, but these days, as you know, people are doing the transfer learning and training for downstream tasks for Bert. So, is there any evaluation on like this Azure system? So, I come from an on-device background, so I don't have much idea about no, cloud deployment. So, my question is like, is there any evaluation or benchmarking
Hmm. Okay.
done, whether for a language model training from scratch or but transfer learning, like where I can find actually the
Okay.
numbers.
Thank you for that question, and check this out. So uh, check this deep called as deep train. And
Victim.
just give me a second. Sorry, a Microsoft. Oh, sorry, Deep Speed. Yeah,
And its speed.
my bad. So Deep Speed from Microsoft. Okay. So we'll go to their website. So what they did, this came out 2, 3 years back.
Okay.
What they did, they were able to train the biggest language model in the fastest possible manner. And this call is Deep Speed. This is Microsoft's open source repository now. It's a wrapper around um other things, like
Okay.
it can also work with PyTorch, Deep
Okay.
Speed. And the benchmark is available there, yeah, on this
Okay.
page, which is the
Okay.
landing page, and it should be
Okay.
somewhere on
Um,
the landing
Down.
page itself. So we will be able to find it here.
Okay. Yeah, here it
Okay,
is.
yeah, these are the ones. So how much time did it took for them to train on this? So
Hmm.
this is where, and the benchmark, and one of the things which they were able to achieve was the biggest model with the most number of parameters in the least amount of time using this. So that's what
Okay.
Azure also uses in various locations behind the scene. This is part of Microsoft research. It's in the chat window.
Okay. Thank you. Thank you so much. So this is from Microsoft, right? This Deep Speed.
Open source. Now it's open source.
It's now open source. Okay. Okay. Thank you. Thank you so much.
Okay. There are many types of transformers, also BERT models. How can we choose the appropriate one? Okay, another good question. So for that, I will use your learn module only. So if you go to your learn module, and the one of the unit which I skipped because we are about to hit the time is this one. So when you will click on the unit number 4 or the fifth one, not this, the next one, you will find that we here that various architectures are defined, and based on these architectures the use cases are defined over there. For example, the one which we did was this one, many to one, which we were talking about, like text classification. What happens if we have one to many? For example, you give the input image and you are looking for caption of that, like is the man walking in the image or not. So that will be one to many over there. So based on different architectures, different things are achieved, and it's in the unit number 5 in your learn module. So find it. Okay, so uh, okay, in case okay, so what we do is we do these sessions very regularly. We keep on experimenting with the latest things as such. So if a few of the previous sessions you should be looking for will be the one where we trained the ML model with on Kubernetes last week, and before that it was using Spark operator, using other things as well, not Synapse like open source Apache Spark. So Spark was installed inside Kubernetes, and then on that we trained it. So all of those sessions are already done. In future, we are having more sessions, pretty interesting sessions on different type of data sets, like how NASA uses data science to do some analysis on the moon rocks. That's one of the session which I'm also looking for. It's coming up. Is coming up, and you can find those sessions if you join the Reactor group on LinkedIn, or if you join the Meetup group, which from where you came, or maybe you find me on LinkedIn, or maybe Rashmita, and you can join all these locations and you can get the information about the upcoming sessions.
Thank you, Shivam, so much for this session, and thank you all for joining us today. Please do share your feedback about today's session, and like Shivam said, please go through the Learn module, which is already shared in the chat section, and also I'm displaying on my screen right now. It will just give you access to additional resources. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again.